Hello guys, we have a question here that says a metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degree with the horizontal. The rod is not allowed to slide down by flowing a current through it. When a magnetic field of induction 0.25 T is acting on it in the vertical direction, the current flowing in the rod to keep it stationary is okay. So let me draw a diagram for you. Rough diagram. This is our mg sin theta. Just 30 degree. Cos 30 degree. Okay. The angle is 30. This is B. This is F. Okay. So we know B is equals to 0.25 T. It is given in the question. Okay. So B is equals to M by L. That is equals to 0.5 kg per meter. Okay. So B is equals to also M by L. Okay. So theta is 30 degree. It is given in the question, and F is equals to BIL. F is equals to BIL. Okay. So put the value of F in the given formula. That is our F cos 30. Sorry, like F cos 30 balances mg sin theta, as you can see in the figure I have drawn. Okay. Now we have to multiply it, both sides with cos 30 and cos 30 and sin 30. We compare both of these, like we transpose the IL to the F side, and we compare the with ML, M by L, and F by IL. Okay. Then we get BIL cos 30 equals to mg sin theta. We get I equals to M by L G by B sin 30 by cos 30, and we get in the end the answer is 7.32 A. Okay, this is our solution. 7.32 ampere.